Gentlemen, we're just starting a little bit late because it was taking a little bit of time for the authors to actually get through and find the room. A very good morning to you here. How wonderful it is to be in this marvelous location, particularly this room. It's hard to think of it as work when you come to work in a place like this. So this morning we have, to begin with, the lightning sessions for 3 poster sessions. They are session 1.4, which is the multidisciplinary studies of the Earth's subsystems. Session 3.4, integrating data from different monitoring technologies. And session 5.1, synergies with global challenges. So, without further ado, I'll invite the first author to come up and to make their presentation. Usama. Usama?
Good morning, everyone. My name is Osama Kadri. I'm a reader of applied mathematics at Cardiff University. We've been developing the early tsunami warning system using acoustic gravity waves that are recorded on the hydroacoustic stations of the CTBTO. Unlike traditional systems where the tsunami needs to physically be on the sensor or it is concerned earthquakes, acoustic gravity waves are generated from different sources. By compressing the water layer, acoustic gravity waves travel much faster than the tsunami and they carry information about the source. The strength of our technology relies on the analytical models. They are very quick, so we can make the assessment globally within a few seconds, tens of seconds. We have also machine learning models as well that run in parallel to these. We've deployed the technology last year, and we were hoping to pursuing the deployment in other warning centers around the world with the help of the UNESCO IOC. Next, please. In this problem, in this study, I've been looking into the acoustic gravity wave signatures recorded on hydroacoustic stations from airplane crashes. For example, the F-35A, the Japanese airplane. Where the signature, you could see the signature at a distance of more than 3,000 kilometers. An interesting case also that I've been looking at is the implosion of the San Juan submarine, the Argentinian submarine. The interesting part is that apart from that, it was also recorded at very long distances, but it also was recorded on a nearby hydroacoustic station, but crossing more than 2,000 kilometers of land. When it came to MH370, the missing Malaysian airplane, there is no signal. And the so-called seventh arc is at about 1,500 kilometers, which is half of the distance compared to the F-35A. And the question is, why is that? Is it because the conditions of the ocean did not allow the recording, or is it because the airplane did not crash there? If you want to hear more, I would be happy to chat with you later on. I would be between boards 1 and 2. Thank you.
Good morning, ladies and gentlemen, and I'm very happy to present our work. We present a case of induced seismicity in northern Guatemala, linked to severe flooding from tropical storms Eta and Iota in the Saturate 2020 hurricane season. The epicentral area dominated by carbonate rocks, hosts a complex karst system. Seismicity was likely triggered by direct hydraulic connection and pore fluid diffusion, evidenced by timing of rainfall and seismicity. Frequency domain correlation analysis indicates activation of multiple cracks or minor faults in a tectonically predisposed setting, posing significant seismic hazard in the area. This is the first instrumental record of such meteorological induced seismicity in Guatemala karst environmental. Please visit the poster for more details. Thank you very much.
Good morning. My name is Martin Brandt. I'm a seismologist and I'm from the Council for Geoscience in South Africa. And my poster is about open cast mine explosion confirmation in South Africa with infrasound waves recorded at station I-47. The Council for Geoscience operates the South African National Seismograph Network. We routinely locate earthquakes, mine-related events associated with South Africa's deep gold mining events and platinum events, and then quite a lot of explosions associated with open cast mining in South Africa. We currently, as a routine practice, identify these explosions on Google Earth if they are associated with a mining pit or mine infrastructure, also from the time of day plots. But still, those are suspected explosions, so we wanted a better method to confirm these explosions, the reason being that these events get removed from the earthquake catalogue before seismic hazard analysis is performed. So we decided to try to see whether infrasound can be of help. We acquired the InfraP software, that is infrasound analysis software. It is freeware software, it's available from GitHub. And we started analyzing signals associated with these blasts. So we use it as a confirmation technology. So we look for signals at the predicted arrival time, the predicted azimuth, and also the predicted apparent velocity. We started in April last year to 2024, and we were able to now confirm explosions in all of the quarries that we have recorded suspected explosions with the South African National Seismograph Network. What we found, though, is that most of the explosions do not generate infrasound signals detected by IMS station I-47. Maybe it is because explosions are too small, but we also observed an interesting seasonal pattern. Interesting seasonal pattern in that most of the events in May and June originated from the west of the station, and most of the events in January and February recorded to the east of the station. Thank you.
Good morning, I'm Michael Fox from Pacific Northwest National Lab, and I have a poster on some work. We had a team there that was working on evaluating environmental variations and hazards and the impact on the radionuclide stations within the IMS. So looking at things like flooding, cyclones, kind of high winds, drought, heat, precipitation, humidity, and dust to understand what's the quantifiable impact that those may have on the radionuclide stations over the next 25 years. So if you come to my poster, I'll walk through kind of what we find for each of those parameters. Thank you.
Good morning. I am Rémi Bossu. I'm in charge of the Euromed Seismological Center. So the European Mediterranean Seismological Center provides rapid information on earthquakes and their effects. To do this, we collate the data from nearly 120 seismic networks around the world, and we crowdsourced felt experiences from eyewitnesses. Last year, we reported more than 100,000 earthquakes, and we collected nearly 400,000 felt reports. It is the most comprehensive open global seismic event and macroseismic catalog which is available. We also detect seismic events which are not earthquakes, so like bolids, meteorites, explosions, and some events that are not reported by any seismic station, at least to us. Our data are widely used. We have 1.5 million daily requests on our web services, and we have 10 million views a month on our different platforms. So we welcome any new contributions. So if you want to participate, you are welcome, and I will be next door to discuss it. Thank you.
Good morning, everyone. My name is Pedro Paulino. My partner is Jotin Leonel. We are from the National Seismic Center of the Universidad Autónoma de Santo Domingo, Dominican Republic. We are presenting as a seismic analysis using the SSEV tsunami potential generate events. We took for these fingerprints almost like all the events registered and validated by the IDC of the CTVT on the 2024. Sorry, because I haven't the poster right here, but you will be there and I will give you details. And you're gonna see how the architecture of our work is represented by these events. There are no random, as you may know. You will see that this catalog have a really strong fingerprints of these events. Even so, you will be able to compare with other catalogs as USGS and see how this just not make a tool that can show us how the events in the occur on the planet. If not, also will be able us to see potential risks for tsunami cause, even so, and help us to be more safely. Thank you very much. I will hope you there. Have a nice day.
So a pleasant morning to everyone. I am Antonio Bonga from the Philippine Nuclear Research Institute, and allow me to introduce you to our poster entitled Effect of 2020 Taal Volcano Eruption on Lead-212 Detection of the CTBTO RN52 Station. So in this poster, we aim to determine if the 2020 eruption of the Taal Volcano located in the Philippines had any effect on the Lead-212 detection of the RN52 station, which is located northwest of the volcano. So Lead-212 is a natural radionuclide which is regularly detected by the radionuclide stations under the International Monitoring System. So this can be quite interesting since increases in the concentration of this radionuclide have been reported in past volcanic eruptions, such as those of the Miyake-jima and Asama volcanoes in Japan. So if you want to know more about what we did and what we found out, come over for a chat in front of our poster. Thank you very much.
Good morning, beautiful ladies and gentlemen. My name is Aydin Mukambayev. I am from Kazakhstan National Data Center, and today I want to present our research about glacier monitoring. After establishing our network, we started registrate some lot of like earthquake swarms in high tension, and to be sure, we was installed another temporary station near this field, and we have a lot of data, and we now have like seasonal and daily variation of these swarms. And if you want to know about more detail, welcome to my poster 25. Thank you for your attention.
Good morning. This is Dr. Mahfouza Parveen, Associate Professor, Department of Environmental Science and Disaster Management, Daffodil International University, Bangladesh. So you all know that Bangladesh is a disaster-prone country, and several kinds of disasters are happening there, like cyclone, flood, and like drought, etc. So, but the earthquake is the hidden disasters, considered as hidden disasters in Bangladesh, because the location of Bangladesh is very vulnerable, because it's situated in the junction of three big plates, that is tectonic plates, that is Indian plate, Eurasian plate, and Burmese plate. So earthquake is one of the major disaster we are counting as one of the major disasters in Bangladesh. For that, I prepared in my posters, we prepared a disaster distribution, earthquake distribution map using USGS data for last 2 decades from 2000 to 2024. And this map will help to disaster preparedness for Bangladesh, and also increase the awareness awareness among the mass people in Bangladesh. So please do visit in my poster and flood me in your queries. Thank you.
Good morning, everyone. My name is Cameron Brown, and I'm from AWE in the UK. So the topic of my lightning talk and my poster today is to provide a bit of an overview about a project that we're currently working on. So essentially, we're interested in better understanding the radionuclide, specifically radio xenon background in the UK, and hopefully using that to inform our understanding of nuclide monitoring. So the kind of main methodology that we're applying here is to deploy an array of sauna cube measurement systems around a pressurized water reactor in the UK, so down in the southeast. And what we're hoping to get out of this is to better understand its fingerprint and use this to extrapolate and better understand these civil sources, these nuisance sources around the world. So if any of that sounds interesting to you, please come and have a look at my poster today, and hopefully we can have a bit of a chat. Thank you very much.
Kia ora. My name's Jo Chapman. I'm from PHF Science in New Zealand. So every day, animals shed DNA into the environment, such as hair, skin, seeds, and pollen. Recently, scientists have started using specialist equipment to harvest this environmental DNA to understand biodiversity. Obviously, the most comprehensive air filtering system in the world is the IMS system to sample air for radionuclides. We were interested to know whether you could recover DNA profiles from these filters that were not designed for this method or for this technique. So we obtained Cinderella and Snow White filters from the CTBTO headquarters. These are outside of the IMS system, so were available for scientific purposes. And sure enough, we were able to recover DNA profiles from these filters. So the wheel that you can see here, each tip is an individual species we detected, including wolf DNA. So if you're interested in understanding why we might detect wolves in Vienna, or what other species we detected, or how this could be used to understand biodiversity on a global scale, please come and visit my poster. Thank you.
Good morning. So our poster is about the geophysical monitoring of volcanic eruption. So as illustrated on this picture by USGS. So presenting the main monitoring method from gas measurements, ground deformation, seismicity, remote sensing. But as you can see, in 2010, infrasound monitoring was not included in this panel of methods, but is now becoming more and more popular and common. So if you want to know how we use infrasound sensor and only infrasound sensor to infer lava eruption and crater morphology changing near Ragongo volcano in Congo, please have a look at our poster. Thank you.
Okay, good morning, everyone. My name is Kegan McGrath, and I'm a Senior Policy Officer at the Organization for the Prohibition of Chemical Weapons. I am here presenting a poster on leveraging competencies and expertise across international organizations in support of global peace and security. And this is a bit of a different kind of presentation. This falls under the synergies with global challenges. And what I've looked at through a project that we have concluded with the OPCW is how we can increase interoperability and effective communication in crises. And specifically for this presentation, we're going to be looking at phase 3 of this project that was conducted under the United Nations Office of Counterterrorism, the Global Compact Against Counterterrorism, which the CTBTO is a member of. We had a few workshops for this project, 2 of which the CTBTO had representatives participating in. The first one was on operation centers and situation centers, and basically looking at different methods and approaches for effective communication with teams in the field, especially when operating in hostile or non-pervasive environments. And the other was looking at deployments and what we can learn across organizations in terms of maximizing efficiency and going on deployments again in sometimes hostile and non-permissive environments. So if you'd like to hear more about this presentation, I'd be glad to talk to you. My poster will be over at number 42. Thank you very much.
Good morning, everyone. My name is Sandro Matos, and I come from IVAR Institute from Azores, Portugal. And I will present a decade of global volcanic events observations at the IMS infrasound network. It's about the correlation of volcanic eruptions from the Global Volcanic Program database with infrasound detections from the IMS network. For that, we designated and validated a detection algorithm, and we systematically applied to 69 eruptions from 2011 to 2020 for 46 volcanoes, and we use data from IMS stations between 400 and 500 kilometers from each volcano, and then we compare it with the CTBT or IDC bulletins such REB, LEB, and CEL3. Our key results shows a strong correlation with the eruptions on the Global Volcanic Program and also with the events in the LEB from the CTBT or IDC bulletins. So if you want to know a little bit more, just come visit my poster. Thank you.
Good morning, everyone. My name is Farida Lawaruma. I'm from Nigerian Nuclear Regulatory Authority. My presentation for today is integrating international monitoring system and national data center into the national nuclear radiological and emergency plans, response plans. Thank you.
Good morning. My name is Anas Mahaita from Jordan Seismological Observatory. My poster shows the importance of integrating data from Jordan Seismic Station with the IMS network. I analyzed 3 earthquakes in Cyprus, Gulf of Aqaba, and Syria, and 1 explosion in the Sea region. The result give more accurate location and reduce azimuth gap. Thank you.
Good morning. My name is Carly Dargatz, and my poster discusses the use of geographic information science, or systems, in building awareness and perception of the CTBT, and the use of geospatial data in building engagement. Building engagement, as well as awareness and communication and trust in the CTBT, requires an understanding of both the environmental and the social impacts of testing and weapons. And visualizing that data enables a better understanding as well as a way to conceptualize the true reality. GIS offers a way to build engagement through various applications, workshops, educational resources. If you're interested in discussing some of the uses of mapping and geospatial data in building public awareness and outreach, come visit my poster. Thank you.
Good morning, buenos dias, bonjour. There's no slide, no image, but if you want to know how to join the use of IMS data for tsunami warning, I'm the right person and I can respond in Spanish, French, and English. Thank you.
Hello everyone, good morning. I'm Adila from Indonesia. I want to deliver our poster. Our poster is about data quality assessment of CTBT auxiliary station Baumata AS45 using template matching and PSD evaluation. In this research, we look at the data from AS45 during the 2021 Floresi earthquake with moment magnitude 7.3, And by using the template matching, we check how well the sensor picks up the small events like the aftershocks. And with the power spectral density or PSD, we measure the background noise and compare it to the Peterson Global Noise Model. As a result, the AS45 stations shows good, reliable data quality for seismic monitoring. Curious to learn more? Come by our poster and let's have a chat. See you there.
Good morning, everyone. My name is Sopon Chaila from Earthquake Observation Division, Thailand. Come over to see my poster if you would like to find out more about Central Plain of Thailand. This research study on seismic hazards microzonation in Thailand. I developed fundamental frequency VS30 and soil classification. Dissolve side effect amplified ground motion exists building design standards by over 5 times in Central Lower Plain. Please come to see my poster. Thank you.
Well, that is the last of our lightning presentations for this session. You're now free to roam the hall and go to the ones that you found most interesting and attractive. And before we do, I'd just like to present my appreciation to the authors as well for sticking to time, which is always an issue with these talks, and for giving us such a broad spread of topics to spend the rest of the morning studying. Thank you very much.